So this one is the review quiz, right?
No, that would be the next one.
Yeah, this is lesson 14.
And this was about the ANOVA. Yeah, this was the one-way analysis of variance. Okay.
Oh, hello.
Okay, starting with question 1. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate that at least one mean is different from the others.
That's true.
Yep. I gotta go grab some socks really quick. It's cold.
Okay. I guess it's cold where you guys are at, so.
Yeah. It's pretty cold in Idaho.
Yeah, it was 90 degrees today.
It was what?
It was 90 degrees here at home.
Oh my goodness. I'm so jealous.
Yeah, you guys are like, I need socks and a jacket. And I'm like, okay, where are my sandals? Still.
That would be so nice.
I don't know. We have a cold front. It's going to be in the 70s on, I think Thursday. Ooh. I know, right?
Chilly.
Hey, that's chilly to a Texan, man.
Yeah.
Especially if it's like 60 degrees at night. So.
Yeah.
Okay, question 4.
60 degrees today.
Ooh. All right.
In Utah, in Idaho.
Yep. Hey, I'm a little bit jealous. I would like to be wearing like warm clothes and scarves already. So maybe next week.
Sweater and my wool socks and my sweats and I'm trying not to turn the heat on a whole lot just because it's so expensive and
right.
we're gonna need it. And it's not that bad yet. So yeah. Okay. Question 4.
Yeah, what requirements need to be checked when performing an ANOVA hypothesis test?
Well, I think it's a first one because it says in one of the things that they can't be negative.
Yeah.
I don't know if it means the means though.
Oh, is it?
Because I think it meant that
that the data are normally distributed.
The F distribution has to be positive. The values of F are never negative. So okay. Is that the sample or is that the F value? F distribution, sorry.
I don't know. I just found in my notes though that the true requirements for the ANOVA test are that the data are normally distributed and that the variances are equal. So I think it's just the last two actually.
Yeah.
Normal distributed and also the variance are equal to in each group.
Okay. Number 5. To check if each group is normally distributed, do the following. Construct a QQ plot for each group.
Yep. Okay, question 6. We assume the variance in each group is the same if the following happens. If the largest variance is less than 4 times the smallest.
That's what I have.
Right?
Yep. And that's as far as I got on starting this, so. All right. Number 7.
Okay, and another hypothesis test is we create to conducting independent two-sample t-test between every pair of samples. If there are three samples, there are three pairs. 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are four samples? Is that 4?
Um,
6?
yeah, that's what I got. 6.
I had to
Two.
like write them out. 1
Yeah,
and
me
2.
too. That's what I was just doing.
1 and 2, 3 and or 2 and 3, 3 and 4,
4 and 5. Oh,
1 and 3,
One.
1 and 4, 2 and 4.
Yeah.
Right? Yeah.
Yeah, that's all I got.
Okay.
Yeah, 6 pairs.
Okay. Soccer shoes.
Woohoo! Okay. There are 5 types of shoes and also just wearing socks. Each row is okay. Okay. Here we go.
So question 8, what is the minimum for the 6 groups?
Well, we have to use thing to figure it out. Oops, wrong one.
Is there 6 groups? I just only see one.
It goes all the way down in the column, so you have to go and copy down to A and then copy B.
Oh,
See how they're separated by, or they have the different numbers or letters.
yeah, I see it.
Oops.
So which one do we use now?
This is the ANOVA table. So it's 1 sample t-test, paired sample t-test, 2 sample t-test, and then the ANOVA test.
The one they talked about in the book.
Oh my goodness, I'm still copying and pasting.
Me too. It's the worst, like clicking between all the different files you have open. That's what takes so long.
Oh yeah, and you're like, wait a second, that's not it. That was the wrong one. Okay, there's all the variables.
What's the question asking?
What is the minimum or smallest variance for the 6 groups? Round to 3
Oh.
decimal places. Okay.
It looks like it's for variable 3, or variable 3.
Yes.
0.208, yeah.
Yeah.
Okay,
What is maximum? 53. 158. The test for equal variances is satisfied for these data.
Which one do you have for the largest? Is it 53.158?
Yes.
Yeah, it is, because 52 isn't, it's not even double the other one, so.
Yeah. So does that mean, and I just want to make sure I'm understanding it correctly, when it says 4 times, you just take whatever the smallest number is times 4, correct?
Yeah.
Okay.
Yeah,
That's
that's
what
how I understand it.
Okay. I was just making sure I was understanding it the same way. So.
Yeah.
How do you know if it's stratified?
You know if it's satisfied if it's less than 4 times than the smallest one.
Which mean like the smallest one is 27.208.
Mm-hmm. Yeah, so you'd have to take 27.208 and times it by 4.
So it has to be larger than the mean.
No, it has to be larger than it has to be 4 times larger than the smallest variance number in the variables.
So it would have to be 4 times larger than the 27 point, or yeah, 0.20.
I'm sorry, I mean, like, what are we using the times for?
Yes, times 4.
Which one? Like 27.208 times 4?
Yes.
And then it has to be
So
larger.
Right. So for number 10 to be true, the largest number, which is, in this example, is 53. But if it was to be true, it would have to be higher than 108.
Oh, okay, got it.
Yeah. Okay. Construct a QQ plot. Awesome.
My favorite.
Okay. Each of the samples are approximately normal based on what you see in the QQ plots. Okay.
Okay, so we just got to do that for all of them.
All right. Number 1. 1 down, 4 to go. Oh, sorry, 5.
How do we do the QQ plot?
You have to open up the quantitative descriptive statistics spreadsheet.
They also had that one listed in the textbook. It was one of the links that they had. If you look through lesson 14, they'll have it in there.
Vincent, how far away are you from work?
10 minutes drive.
Okay.
Oh, do you have to work tonight?
Yeah, I'm supposed to work till 10. But after my manager said I need to go back after the group meeting.
Okay.
Well, we're doing good. We're actually almost done.
Mm-hmm.
Yeah. Okay, QQ plot. And do we just copy the whole thing in?
You have to copy each column separately.
So you do them as like the different variables.
But it just showed one column. It's like, just let me put in one column.
Yes, you just got to do them one at a time.
here.
So I just like place the first variable and then like I place the second variable again,
Yeah.
Yes.
like on the same.
So what I did is I just did them one at a time and just wrote down yes or no if it was normal.
Oh, gotcha.
So far, none of them have been. Is that what you're getting to, Tabitha?
Oh, sorry. Say again.
That so far, like none of them are normal.
I got most of them were normal. Just a couple of them were kind of weird.
The first one is not normal though.
Did you put it in order from smallest to biggest?
Does it have to be small? That would make a difference.
Because otherwise it looks totally weird.
Yeah.
Like they're all spotty all over the place.
Okay. Wonder how much you would mess this up.
Do you know how to like make it like smallest to the largest?
You highlight all of them and then sort. You can do like A to Z or sort smallest to biggest.
So, dang, like, oh, I see it now. Can I just share my screen with you guys real quick?
Huh? Oh, yeah, go ahead.
Can you guys see it?
Yes.
So, this, like, is kind of not normal.
Which one is that one? Is that the first one?
This is the
Oh, that's the second one. Yeah, mine did that too.
So, is it considered not normal then?
Well, I don't know. I guess that one wouldn't be normal, but for the most part, the data that is on it, the data is normal, even though there's that little curve on the bottom part of it. So
Okay.
just says, let's see. If the points in the QQ plot do not show distinct curvature, it is reasonable to conclude that the data are normally distributed. But is that all of them, or you see?
Well, I guess as soon as we have one that's not normal, we can say it's false because it says each of the samples are approximately normal based on what you see. So even if one of them is off, it would be false.
Yeah.
So.
But see, But if you look at the homework, or I'm sorry, the preparation assignment, if you look at the solutions
Mm-hmm.
and look at 7B, so like those aren't exactly what would be considered totally normal, but this one says
That
the
they're
QQ
close.
plots show that they're not perfectly, but they're probably close enough to proceed with ANOVA.
Okay.
And one of them had like the funny, where it went out on the ends were like a little more curved than they normally would be.
Yeah.
I don't know. I'm going to feel bad if we get that wrong. Because they're all mostly normal.
We got 2
well,
tries.
right.
Yeah. All right. We had number. Oh, okay. So 11. Did you guys think true or false?
Probably true then, because yeah, like you were saying in the homework, it had some that were a little bit more off than what would be like what we would usually consider normal. But
Yeah.
Oh, and 10 is false, right? 10.
10 is yes. All right, number 12. I love how this says, perform a test in SPSS. We're not using that. Okay, observe that the p-value is 0.081. Remove the SOX data, which is the variable number 6, and perform the test again. What is the p-value when we remove the SOX data?
Okay. So just take that off.
Yeah, just take off that 6th variable. Just delete it.
The p-value will be 0.309.
That's what I got.
yep. So I say that one more time.
0.309.
Okay.
Okay. Number 13. Oh, wait.
Yeah. So question 18 or 13. It's been a long day. So the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or to the left of the F statistic? Oh, I
It
had,
would be.
How do we know? How can we tell?
it's to the left. It
Why
has
is that?
I thought it was to the right.
I think it's stay in the middle.
Hold on, let me look at that again. ANOVA is an F. Is the p-value the area to the right or the left?
As for the example in the book, it has F being like over on the left side of the tail, and then the p-value is the red section to the other side of it.
Hey, and just a quick question. Do you guys know if that is any way we can look at the exam 1 to see what we did?
If we can look at exam 1,
Yeah.
you had to set up a meeting with Stephanie.
So we cannot just see it like online.
Yeah, you can't just see it. Like they have to open it for you. Like she opens it on her computer for you to look at, and then that's it.
Okay.
which is kind of a bummer.
Mm-hmm.
Okay, so in the book, I see where it says the p-value for the ANOVA test is to the area in the right tail. Let me see if I see it someplace else.
Okay.
P-value for the ANOVA test is area in the right tail. You never
Oh, yeah. Okay.
the area in the tail. Excuse me.
Oh, bless you.
Thank you. So it's right then. Choose the right.
Yeah.
Good way to look at it.
Okay.
Almost there. Almost there.
Almost. There's a handful left.
5 more.
Okay. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat.
Ugh.
Now I want a hot dog.
For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the Excel spreadsheet. Use this data file to answer the remaining questions. Let's examine the calories first. Construct QQ plots for the calories of each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use an ANOVA test are met.
So we
Okay.
put that plots into a
Yep. For the calories.
Okay.
Should we look at the options for the answer real quick?
On what? Oh,
The answer. We have met. If the variants are equal.
what in the world?
No.
Oh, there we go. Okay.
So for this, they all look like they're kind of normally distributed, right?
Mm-hmm.
Okay.
Oh my gosh, this one, the answer choices are ridiculous.
Yeah.
Oh, wait. I guess it would be the first choice.
That's what I was thinking. That seems like the best answer.
Yeah, you see the other ones, the assumptions have not been met. While it's safe to assume each group, we cannot assume the variances are equal. Not safe.
Did you guys find the variances with
Hold on.
the other one? That might help us out a little bit if we find that.
Is the
Yeah.
variance opposed to the deviation?
Okay. All right, so
Okay,
I have
yeah,
them in my table now.
Yeah, me too.
Okay, so
It
yeah,
looks-
number 14, I agree. It'd be the first choice.
Yeah.
Okay, is that what you think too, Vincent?
Yeah.
Okay.
I just so I don't know.
One seems like the best option.
Mm-hmm.
Okay.
Okay, then question 15.
Number 15. Run an ANOVA test to determine if the mean number of calories is the same for all three. You should find that the degrees of freedom are 2 and 51, F equals 16.074, and that P equals 0.000 with a level of significance equal to 0.05. What conclusion can you draw?
I think it is the.
Wow, those numbers are really interesting.
Yeah.
Wait, but okay, so my p-value isn't 0.000.
It's like the 3.8 something, right?
Yes.
Okay, and then do you see how at the end it has like the e to the negative 0.06?
Uh-huh. Yes.
That's like all the way over, that's just where it starts in the decimal places, but it's like way over. So,
Right.
yeah. Okay, so for question 15, I think it's the second one that we have the last one, that we have sufficient evidence to claim that at least
Right.
one of the hot dogs has a different mean.
Yeah.
So which means 15
So, sorry. 15
oh,
is the fourth option.
Yeah, the last one.
So, okay, just going back to what you said real fast, even though the question says the p equals 0.000, and now what are you saying? Because the p-value on the 3.86207e, the
Okay.
negative 0.6.
When it has like an e to something, it means
Uh-huh.
many decimal places. That means there's that many zeros before the number starts, or something like that. I'm not sure exactly. I just know that it means
Oh, okay.
0.0000 something, and then it's those numbers.
So if it had been like 3.86207 without the rest of it, then the p-value would be 3.862.
Mhm.
Okay.
But because they tacked on the e,
Okay.
it means like
It's 0.000.
Yeah.
Okay. Well, I learned something new.
I don't know like the exact way that works. I just know that if it has like an E, that means there's like some zeros before the number starts and it's a really small number.
Mm-hmm.
If you want something more specific, you might have to look it up. Probably explain it a little better.
No, it makes total sense. Okay, now we have to do the sodium levels.
Oh, joy.
Okay. I do like these QQ plots though.
Yeah.
Like it's great because if you have less than 30 pieces of data, it'll tell you if it's normally distributed or not.
Yeah.
Plus, I was having one of those like, I will never use statistics in my real life. Totally used it last week. It's
Oh,
crazy.
yeah?
Uh-huh. And it had to do with like the sample sizes for how we compare like our unit data versus the census tract versus the county data when we're doing trying to figure out like fair housing for our apartments. It's crazy.
Yeah. Wow. Cool
I
stuff.
was like, it makes total sense. And I get it. So yeah, thanks. I was quite proud, like, all right.
That's awesome.
All right. I hate how much information there is in like the options for this one.
Yeah, because that just makes it super specific.
Yeah.
To make them all right. Okay.
I don't get it.
I think it's either the first one or the second one because the variances are equal for sure. But I'm not sure just because it's kind of so iffy with how the QQ plots are. I think it was the one that was like questionable or the last one.
Yeah, the last one. But the rest of them are kind of normally distributed, so.
Yeah. But it would have to be all of them for that to be, or safe to assume that each of them comes from it. So right. I'm just not sure like how far off, like if the standard seems to be different for these, like how far off is too far off.
Mm-hmm. I'll look at that again.
But we get 2 tries.
Yeah, because that. Yeah. First or the second one?
Or the first or the third one, sorry.
Okay.
So the first one says that that the assumptions have been met and that they're all normally distributed and the variances are equal. And the third one is that they're not normally distributed, but the variances are still equal. So
Okay.
I'm gonna try the third one.
Oh,
See if that works.
yeah, yeah. All right, 16. Oh, well, that was 16. Just kidding.
17.
Oh. Despite the possible problem. Oh, sorry. Go ahead.
Go ahead. You good?
Oh, okay. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? Okay, so I'm guessing that it means they probably didn't count that one as being normal then.
Yeah.
So for question 16, it would be the third one.
Okay.
All right, so the QQ plot, I mean, not that, the p-value.
Yeah.
Wait, 0.179?
I have.
What conclusion can you, okay, yeah, sorry. Number 18. What conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level of significance, oh my goodness, significance, 0.05.
I think it's the second one.
Even though it's higher, the p-value is higher?
Sorry, hold on just a second. Sorry. Okay. Yeah. I don't know. I think, well, because we would fail to reject the null hypothesis. I think it's the second one.
Nice to see your face too.
I'm doing a school assignment. I'm doing a school assignment. I'm almost done. Okay.
I think it's the second one.
Okay.
Yes, it is.
Okay. Oh, and that's the last one. Fantastic.
Mm-hmm.
Let's see how we did.
Oh, we missed one.
Question
Please
10.
don't do.
Which one?
Question 10.
Okay, now I feel bad because I think that's the one where I was like, it's false. No, I did number 11.
Oh, I put true for number 10 and got it right. So I got so all the rest of them are right. I must have just hit the wrong one, but it worked out because it was the right one.
I don't remember if it was number 10 or 11 that I was like, no, it should be this.
I don't remember either.
I don't either. Sorry. All right. Well, that's the only one I missed. So I just have to go in there and redo it real quick, and I'm done.
Okay.
So.
Yeah.
How about you, Vincent?
Yeah, I mean. So, and can we meet Wednesday? Because like Thursday, I have to work 2:10 again.
Oh my goodness. Yeah, that's.
Yeah,
I mean, that's normally when we meet
Yeah.
anyway. And then I already know that next week, I have to go, like, out of town for work just for the day. But I don't know that I'll be back in time to meet Wednesday night.
Thursday has been working better for me, so if we meet on Thursday, whenever possible, that would be okay with me.
Okay. All right. As long as I just wanted to give you a heads up on that because I know that because I already know that I'm going to be gone. So.
Yeah, next week I can do Thursday. Just this week.
Okay.
Is that okay for you, Ashley?
Sorry, what was that?
Is it okay for you if we meet tomorrow?
Yeah. Would it be possible for us to meet it maybe a little bit earlier, like at 6? Would that work?
I can, because I get off work at 6 and I have to drive home. So, but I'll be like
Oh, okay.
maybe
Okay.
6.
Yeah, 6:30 I guess works. I'll probably have to leave by 7 though.
Well, what if
So-
we tried for like 6:15?
Yeah, I can do 6:15 for sure.
Okay. 6:15 then.
Let's
Yeah.
do that then.
Okay,
So that's
sounds good.
6:15. So 7:15 my time. Okay.
Okay. Yeah.
All right.
Sounds good.
That'll
I'll
work.
see you guys
All right.
tomorrow then.
All right. Sounds good. All right.
Yeah.
Good night, guys.
Bye.
Bye.